Welcome back to Pre-Algebra, Chapter 4. See, there it is again. Chapter 9, Section 4. How many times did I switch those numbers in my head? Alright, so this is the last section we're going to do in Chapter 9. It's going to be a short one because your book tries to teach you everything in high school all at once. And I don't think you can learn it. I think you need to learn things a little bit more slow so you remember it. Now, this is definitely something that was not part of pre-algebra traditionally, but I thought we'd just go ahead and learn it. Okay, and it is real numbers. Now, how you learn the difference in real numbers is knowing the opposite. What's the opposite of real? Imagination. Something called imaginary numbers. And that's why I have SpongeBob, because he goes, imagination. Alright, so what's an imaginary number? You're like, this is crazy. Yes, it is. And it's something that was not around when I took this. And this is, so let me explain to you. Remember square root of 4. 4 is in Arkham Asylum for the criminally insane. So we factor tree him. And he's either made out of 2 times 2. So 2 gets out and the other 2 goes away. Or he's made out of -2 times -2. Either he's a hero like Jim Gordon or he's a villain like the Joker. We don't know. We didn't buy the origin comic. So -2 would get out and the other -2 would go away. So the square root of 4 is plus or minus 2. But what about -4? Can he have someone get out of jail? No. The only way to make -4 is positive 2 times -2, and they are not twins. I would much rather have $2 than owe you $2. If I have $2, I'm off to Dollar Tree, I'm getting some candy, maybe some lotion. $2, I'm sitting at home. Because, I can find the tax. I'll dig down underneath the car cushions and I'll go. So the answer to square root of -4 is no solution. And that was the answer when I was in high school. But then come along and now they're saying, yes, but what if there is an answer? And we'll call it imaginary 2. You can tell I think this is dumb. So when I heard about this, I said, this is the emperor who's not wearing clothes. This is absolutely stupid because there is no solution. So whoever thought of this was not me. Because if I thought of it, they'd say, you're a dumb little high school math teacher from Georgia. And they would laugh me off of the math map. I said, this was somebody fancy, some emperor who's wearing no clothes. Sure enough, I think it was a Harvard professor. His picture is in the Algebra 2 book. I forget his name because I'm not impressed. So I am just in a big campaign. No imaginary numbers, they're stupid. But you have to learn them and you have to do stuff with them in Algebra 2 and up. Well, then I have these kids, and they're all in college, and they're all STEM majors. And my son Nathan has actually told me the only thing you can do with these imaginary numbers is do these pretty little art projects called fractals. And I see no point in those. I can make art without making up math that doesn't exist. So I said, no point, it's stupid, but you just have to learn it. But then my son Nathan said there are some math proofs that you can prove if you go through imaginary numbers, and we don't know how to prove it otherwise. And I thought, okay, maybe. I'm still not convinced, but I don't hate on it quite as bad as I used to. And that's why I'm a nerd. That I can feel this passionate about something this nerdy. That's definition of math nerd, right? Alright, so that's a real, so what is a real number? It's not imaginary. What is imaginary? It's the square root of a negative number, which you can't do. The real answer is no solution. That's what it was when I was in high school. I liked no solution. Now it's imaginary 2. Alright, so the other one is irrational versus rational. And it's the same way. The best way to learn it is to learn it together. So what is an irrational number? An irrational number is something that is a decimal that goes on forever without becoming a pattern of repeating. For the famous one you know is pi. 3.14159 on and on forever without setting up a pattern of repeats. Another one is square root of 2, square root of 3, square root of 5. All of those are irrational numbers. There's another one that has to do with logarithms, natural logarithms. It's pi's less famous cousin. So irrational numbers go on as a decimal forever without setting up a pattern of repeating. So what's rational, not irrational? They're things that can be written as a fraction. Like 2 divided by 3 is the repeating decimal 0.66666 forever. If you do it on your calculator, the last one will say 7, but it's just because they rounded it up. 1/3, 2/3, 5. Anything number that can be written as a fraction is rational. Okay? Now, what we do with this as pre-algebra students is we say which is greater. So, square root of 2 or 9. You do square root on your 2 on your calculator, and it's 1.41 numbers forever, or 9. So, which is bigger, 1.4 or 9? 9. So, Pac-Man wants to eat the greater one, which is 9. Okay, and then the other thing is you might have some things that are fractions, some irrational numbers, some rational numbers all together, and they'll have you put them in order from least to greatest. So what you do is you turn them all into decimals and round them off to the same place. See, I have it to one decimal place on every one of them. You got to make them all the same or you'll get confused. Then you look and you see, okay, which one is the least? Well, the one that's most negative is 2.8. So I write negative 2.8, comma, and then I'll mark it out. When you write it in order, you go back to writing it how it was originally, not turned into a decimal. So the next one is this one. So I write negative square root of 5, mark them out. The next biggest one is 1.3, so I write 4/3, mark it out. And then the biggest one is 1.7, I write square root of 3, mark it out. And then I always have to mark it out or I will leave one behind and get it wrong. This is a classical pre-algebra problem, this not so much. Okay, so come back and we'll do chapter 10. Math is great.